Hey guys, what's up? So today we're going to be looking at octal numbers, and octal numbers are numbers to the base 8. We therefore use the digits 0 to 7, which is 0, 1, 2, 3, 4, 5, 6, and 7. And it says since the number base or scale is 8, each digit in a number has a place value in terms of powers of 8, just like base 10, just like base 2, just like base 4, except it's in terms of powers of 8. Okay? All right. So octal numbers are used by computers as a shorthand for binary numbers. Okay, so this is just an application of what it's used for. Okay. And let's look at this number in base 8 here, 76401, right? So this 7 would represent 7 times 8 to the 4, which is 7 times 4096. Then this would be 6 times 8 to the 3, which would be 6 times 512. Then this would be 4 times 64, 4 times 8 to the 2, which is 4 times 64. Then 0 times 8, right? 0 times 8 to the 1. Then this one would be just 1 times 8 to the 0, which is 1, right? So let's back out our calculators here, guys. So 7 times 4096 would actually give us 28,672 plus 6 times 512 would give us 3072, right? 3072 plus 4 times 64 would give us 256 plus 8 times 0 would give us 0 plus 1. All right. So we're going to add up all of these now. 28,672 plus 3072 plus 256 plus 1 would give us 32,32001. All right. In base 10. Okay. All right. So that's the answer, guys. So, right. So let's look at some other base 8 examples now. Not too hard. Everything is just in powers of 8. And we can look at some other examples now, some simpler examples. This was a pretty medium-sized example to show you as the first example. But let's look at some other examples now. All right, guys. So let's look at two more examples now. And let's look at the first one. It says convert 2405 to the base 8 to a decimal number. All right, so let's look at that. 2405. This should be equal to, let's start with 5. 5 times 8 to the 0 plus 0 times 8 to the 1 plus 4 times 8 to the 2 plus, for 2 now, 2 times 8 to the 3. All right. Okay, so it's 5 times 8 to the 0, which is 5 times 1, plus 0 times 8, plus 4 times 8 squared is 64, plus 2 times 8 cubed, which is 512. All right. All right, so we should end up with 5 plus 0 plus 4 times 64 should be 256 plus 2 times 512 should be 1024. All right. And the answer we should get should be 128 1285, okay, to the base 8. All right, guys. Okay, so not too bad. Pretty easy, right? So the answer for this one is 1285 to the base 8. All right, guys, so great. Wonderful. It's easy, and the answer is 1285 to the base 8. All right. Cool. So let's move on to the next one. All right, guys, so let's look at the next example, which is 743.11 to the base 8. All right, so let's start with the 3 here. This should be 3 times 8 to the 0. This 4 should be plus 4 times 8 to the 1. And this 7 should be plus 7 times 8 to the 2. Now there's actually a octal point here, right? So this 1 is actually going to be 1 times 8 to the negative 1 plus 1 times 8 to the negative 2, all right? Okay, so this should end up being 3 times 1 plus 4 times 8 plus 7 times 8 squared is 64, right? Plus 1 over 8, which is the same thing as 0.125, plus 1 over 8 squared, which is 1 over 64, which is actually 0.05, no, which is actually 0.015625, all right? So 0.015625, okay? All right, so when we add all of these now, we should end up with 3 plus 4 times 8 should be 32, right? Plus 7 times 64, which is 448, plus 0.125 plus 0.015625, okay? So the answer, when you add all of these, right, you should actually get 483.140625, okay? And that's the answer. All right, guys? Great. So let's move on to converting from decimal to base 8, okay? All right, guys, so now we're going to look at converting from decimal to octal to base 8, okay? So let's look at the first example, right? We have 98 to the base 10, and we want this in base 8, okay? All right, so it's the same way we do it with all the other bases, right? With base 2 and base 4. We're going to divide this 98 to the base 10 by 8, okay? And, right, so we're going to divide it and find the remainders, okay? So dividing this 98 by 8, we get 12 and remainder 2, okay? And if we divide this 12 by 8, we're going to get 1. 8 can go into 12 one time and leave a remainder of 4, right? Then this 1 divided by 8 would leave 0 and remainder of 1, okay? So we're going to end up with, we start from bottom up just like we did with the others, and it's going to be 1, 4, 2 to the base 8, okay? All right, so not too bad, guys. Let's look at another example now. All right, guys, so we're going to look at a much larger number in base 10 now, and we want this in base 8, okay? So we're going to do the same thing, 985 to the base 10, and then we're going to divide this by 8 multiple times in order to find the remainders, and the remainders would be equal to the number we need, right? So we're going to divide this 985 by 8, and we're going to get 123, and that leaves a remainder of 1, okay? Then we're going to divide this 123 by 8, and we're going to get 15 with a remainder of 3, right? Then we're going to divide this 15 by 8, and we're going to get 1 with a remainder of 7. Then if we divide this 1 by 8, we're going to get 0 with a remainder of 1, okay? So the number in base 8 would be 1, 7, right? 3, 1. Remember, we'll always read bottom up. All right, and that would be the answer. So the answer for 985 in base 8 would be 1731 in base 8. Okay? All right, guys. So let's look at one last example. Okay? Let's look at one last example, guys. All right, guys, so we're going to look at this example 32001, which was actually the first example in the beginning of this video. Okay, so instead of doing the opposite, which we found the decimal number from base 8, now we're going to find this number in base 8. Okay, so let's just divide this by 8, right? If we divide this by 8, we should get 4,000 with the remainder 1. Okay, and then if we divide the 4,000 by 8, we should get 500 with the remainder 0. And if we divide the 500 by 8, we should get 62 with the remainder 4. And if we divide the 62 by 8, we should get 7 with remainder 6. And then if we divide the 7 by 8, we should get 0 with remainder 7, right? So we end up with the same number, right? We're going to read it bottom up, right? We're going to get 76401 to the base 8, right? 76401, okay? All right, so we end up with the same number we had at the beginning of the video, which is pretty awesome. So we know what we're doing is right. We're confident. You know what I mean? We really are confident. All right, so we can move on now to adding octal numbers. Okay. All right, guys. So we're gonna be looking at adding and subtracting octal numbers, but we're gonna start with adding. And you can see from the table here that this is the complete table for adding numbers in octal, right? So 0 plus 0 would give us 0, 1 plus 1 would give us 2, 2 plus 2 would give us 4, 3 plus 3 would give us 6, 4 plus 4 would give us 1, remainder 0, right? Because 8 would give you 1, remainder 0. 5 plus 5 would give you 1, remainder 2, right? 8 goes into 10 one time and leaves a remainder of 2. 6 plus 6 would be 1, remainder 4, and 7 plus 7, which is 14, would be 1, remainder 6, right? So this is pretty much a table here. And let's just do an example, right? We're going to add 675 to base 8 plus 204 to base 8. So 5 plus 4 should give us 9, right? So that would be 1, remainder 1, right? Just like 5 and 4. 1 are 1, right? Then this 7 plus 1 would be 1, remainder 0, right? 1, remainder 0. Then 2 plus 6, which would be 9. This would be the same thing as 1, remainder 1, right? Then this one is just by itself, so you'd end up with 1, 1, 0, 1 to the base 8. Cool? All right, so let's look at another example. All right, so this example says 4763 to the base 8 plus 215 to the base 8. So let's just add these. 5 and 3 would give you 8, which is 1, remainder 0. 6 plus 1 would give you 8, 0, remainder 1. 2 plus 7 would be 9, plus 10, which would be 1, remainder 2. Then 4 plus 1 would give us 5. So it's 5200. Well, sorry, no, not 5200. 5200 in base 8, right? Yeah, because we're in base 8, so we're not counting in hundreds. Everything is in powers of 8, right? Okay, so we're going to move on to subtraction now. Subtraction of octal numbers. All right, guys, so we're going to look at subtracting numbers in base 8 in octal, right? And we use similar rules as those for addition of octal numbers. So it's pretty similar, guys. All right, so let's subtract this one here. Let's do the first example. We're going to do 2 examples. And we need to subtract 5 from this 2. Okay, so we have to borrow from this 3. So we're going to get 2 here. And we're going to get an 8 plus the 2 here. So that would be 10 minus 5, which would give us 5. Then 7 minus 2, we'll have to borrow from here as well, right? So we'll end up with 5, then 8 plus 2, which would be 10 again, and 10 minus 7 would give us 3. Then 5 minus 4 would give us 1. Then we'd have 7135 to the base 8. So that's the answer. All right. All right, 7135 to the base 8. And that's the answer, guys. And let's move on to the next one. All right, so 3, we'll have to subtract 3 from this 1. Well, we have to borrow from this 7, so we're going to end up with 6 here. Then we're going to end up with 8 here. And we'll have to borrow from this 8, so we're going to get 7 here. Then we're going to get 8, right? So it's 8 plus 1, and 8 plus 1 is 9 minus 3, which would give us 6. Then 4 minus this 7 would give us 3. 0 minus 6 would give us 6. And then 5 minus 6 would give us 1. So this one is 1636 to the base 8. All right. All right, guys. So this is pretty easy. All right, pretty easy. Let's move on to the next one. All right. All right, guys. Okay, guys. So we're gonna be looking at multiplication of octal numbers, and here we are with another table, right? So 0 times 0 would give us 0, right? 0 times any number here would give us 0. 0 times any number here would give us 0, right? Then 1 times 1 would be 1, okay? 2 times 2 would give us 4. 3 times 3 would give us 9, which would give us 1 remainder 1, right? 8 can go into 9 one time and leave a remainder of 1. And yeah, 4 times 4 would give us 16, okay, which would give us 2 and a remainder of 0. 5 times 5 would give us 25, which would give us 8 can go into 25 3 times and leave a remainder of 1. 6 times 6 would be 36. 8 can go into 36 4 times and leave a remainder of 4. 7 times 7 would be 49. 8 can go into 49 6 times and leave a remainder of 1. So you kind of get the whole gist here of this table, right? Okay, so let's do 2 examples, all right? Let's do 2 examples, okay? Let's say we have 761 times 30, and this is all to the base 8. Cool? All right, so for the 30, we're just going to put a placeholder here, right? For this 0, we're not even going to multiply the zeros because it just would end up with 0. And then 3 times 1 would give us 3, just like in the table. 3 times 1, 3, right? 3 times 6 would give us 18. 8 can go into 18 2 times and leave a remainder of 2. Let's look at that. 6 times 3, which give us 2, 2, right? 8 can go into 18 2 times and leave a remainder of 2. So we end up with 2. And then we're going to put that 2 down here. Then 7 times 3 now would be 21. Let's look at that. 7 and 3 would be 25, right? 2 and leave a remainder of 5. And then we're going to add a 2 to it. So it would be 2 and leave a remainder of 7. So 2 here and then a 7 here. Then there's nothing here, so we'll just carry this 2 down and we're going to end up with 27230 to the base 8. And that's the answer. All right, guys? Cool. All right, so let's look at the next one. Let's do another example. All right, guys, great. So let's look at this example, right? 6017 to the base 8 times 472 to the base 8. So let's do 2 first, right? 2 times 7 would give us 14. So that would give us 1 remainder 6, right? Yeah, 8 can go into 14 one time and leave a remainder of 6. Then 2 times 1 would give us 2 plus 1, which would give us 3 here. And 2 times 0 would be 0. Then 6 times 2 would be 12, which is 1 remainder 12. 1 remainder 4, right? And then it would be 1 here. So it's 14036. And the next one now, we'll put a placeholder here. 7 times 7 would give us 61, right? So put a 6 here. And then we'll put a 1 here. 7 times 1 would give us 7 plus 6. And 7 plus 6 is actually 13, right? So 13 would actually be 1 remainder 5. No, it wouldn't be remainder 5. Yeah. 13 would be 1 remainder of 5. Yes, 8 can go into 13 one time and leave a remainder of 5. All right. So this 7 times 0 now would give us 0, but there's a 1 there. So 1 here. Then 7 times 6 now. 7 times 6 should be 5 with a remainder of 2. Right. So we're going up with 5, 2, 1, 5, 1, 0. Right. And the last one now we'll have 2 placeholders here. Then we're gonna have 4 times 7 should give us 28. And right, 4 sevens would give us 28. Then we'd have 3, right? 3 with a remainder of 4, right? Right here, see here. And then 4 times 1 plus 3 would give us 7, right? 4 times 0 would be 0. And then 4 times 6, right? 4 times 6 should be 3 remainder 0, right? So it would end up with 3 over here, remainder 0, and then this 3 would come down here, so it would be 3, 0, 0, 7, 4, 0, 0. Okay, so we're gonna add all of these 3 now. All right, cool. So we're gonna add all of these 3 now, and we should actually get 6, 4. This 5 and 4 would be 1, remainder 1. Then we'd end up with 1 remainder 5. Then 2 plus 1 plus 1 will just give us 4. Then 5, 3. So the answer is 3, 5, 4, 5, 1, 4, 6 to the base 8. Okay. All right, guys. So that's it for bases. Okay. We're finished with octal numbers. We're finished with base 4. We're finished with base 10. We're finished with all the bases we need: 2, 4, 8, and 10. Understanding these for the exam. And we can move on to just general rules of mathematics now for computation rules. I'm going to move on to computation. Okay. All right, guys. So that's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.